you can clearly see that there is voltage present at the input of the diode within the diode section. Let's test this section as well. You can see the voltage is still present across the diode. We'll also perform this test on the resistor and see that there's power in the resistor too. Thus, we do have voltage right up to the point just before the VSP transformer, just as you can see here. Now, what we need to do is check if we have voltage after the VSP transformer or not. So, up to this point, our electronic components were fine, and we can see we have the necessary voltage across them. Now we need to test what comes after the VSP transformer. What components are located after the VSP transformer? I also need to remove this heatsink to demonstrate it to you with much greater ease and precision. Therefore, I will remove the heatsink and we will discuss the components located after the transformer. I will instruct you on whether there are any components after the transformer and precisely which components are VSP related that require testing. So you've observed that we had power all the way up to the transformer's input, but for added assurance, we will in fact carefully turn the board back over. To begin, I will power down the power supply unit completely, and then I will carefully turn the board over so that we can thoroughly test the transformer component as well. Alright, regarding the VSP transformer, we specifically need to test its input and output to determine the presence or absence of power. Now, among these, which one is the actual core of the VSP transformer? In power supply units, we generally have 3 types of transformers. So 3 transformers that we need to test. The pins that you observe right here belong to the VSP transformer. These 4 pins and 3 pins, where the 3 pins are the output and the 4 pins are the input. Therefore, we'll proceed to check the input and output of the transformers to ascertain the precise voltage status. We'll keep the multimeter in the 1000 volt test range, and now we'll proceed to take a voltage reading at this point. See, these pins belong to our transformer. We come over here. We need to connect the negative probe to a capacitor's negative pin and use the positive probe on the transformer. What's next? We'll measure voltage at the transformer's input, not the transformer itself. We need to check if power reaches and enters the transformer. Okay, I'll place the probe on the capacitor's negative pin and test the first pin. Here, we observe approximately 100 volts of electricity. This pin and the other negative pin shouldn't have any power. This one too is negative, so it won't have power. So we'll test it using its own positive and negative terminals. And we can see that the power is reaching right up to the input pins of our transformer. Alright, now let's measure the output voltage of the transformer to see if we have an output or not. Since transformers work with AC current, we have to set the test to the AC mode. This means we'll set the multimeter to the AC range, and this time we'll test it once more to ensure everything is functioning correctly. This time we're going to test the output power of the transformer. We are no longer concerned with its input. We'll place the negative probe on the negative terminal, and here we can see approximately 13 volts of output from the transformer. As you can clearly see here, we are getting a 13 volt output in AC mode from the transformer. However, to be absolutely certain, we will switch the multimeter to DC mode and retest the transformer's output. You'll observe that it won't be able to show us any power then. What does this mean? Because we're testing the transformer with DC, it means our transformer is also fine. It doesn't show a reading on DC, and it's only on AC that it shows us the power, just as you can see here. Even with the negative probe on negative, you can see the transformer is perfectly fine. So we have power all the way to the transformer's output. Thus, our VSP is completely operational and has been successfully repaired all the way to the transformer output. You see, it was very easy up to this point. Now let's find out why we don't have the VSP voltage. We should ideally have the VSP voltage by now, assuming no other components are faulty. Therefore, we'll proceed here and we'll test if we have the VSP voltage. I'll connect the negative probe to one of the negative sockets. Connect it this way. It doesn't matter which negative wire you connect to. With the positive probe, we'll measure the VSP voltage on the purple wire. Let's check if we have any voltage there or not. Just remember, you must have set your multimeter to DC mode for this test. We'll test it out and find that there's still no voltage present. If the VSD has no voltage, then the green wire definitely won't have any voltage either. Okay, so this issue must be somewhere after the transformer. So we'll perform our diagnostic tests after the transformer to pinpoint which specific component is faulty and requires repair. Alright, as I said, what we need to do is remove this heatsink right here. The reason for taking it off is that we want to test the components located after the transformer and determine whether there's any issue present in that section or not. We'll test them, and so you can see the components more easily, I'm going to unscrew this heatsink and remove it from the circuit board. Okay, so here I have separated this heatsink from the board, and I'm going to put it aside for now. And now, we've reached the stage where we need to test these specific components. Alright, what we need to do is connect the power supply to the electrical outlet, then perform a comprehensive voltage test to pinpoint exactly which component is failing to provide the necessary output voltage. If we are going to test the diodes, it's essential to do it correctly. Diodes on the board will certainly never give us accurate information, so they have to be removed from the board, but we'll still go ahead and perform a test anyway. We'll set the multimeter to the DC voltage test mode, and then, using the probes, we'll take the measurement. What do? As usual, we connect the negative probe to our negative wire. Since the voltage is now on this side of the circuit board, we can easily work with the negative terminal located on this side, and with the positive probe, we proceed with a voltage test. Here, we observe that it actually shows us a rather insignificant voltage. Just as we observe here, we'll take a voltage reading to ascertain precisely which section is failing to deliver an output voltage, thus accounting for our lack of voltage. Alright, so we had sufficient voltage at the transformer's output, which means we had all the voltages we needed right there at the output of the transformer. Now let's go ahead and set the voltage to we'll set it to DC. We'll then check both 20 volts DC and 20 volts AC, and then we'll conduct a test. What we observe here is that, so, as expected, the transformer PIN is giving us the proper output voltage. What we'll need to do is carefully desolder the leads of these diodes from the circuit board, particularly the larger one prominently positioned here. We can see it's the diode that processes the transformer's voltage after it exits both this diode and the one right next to it. You'll observe two diodes, a substantial one and a more compact one. The substantial diode generates the voltage specifically for the IC, while the more compact one supplies the standby voltage. Ultimately, all these voltages converge into this specific IC, the power switch IC right here. It not only indicates the standby voltage, but also what occurs when we activate the power. We turn it on. In fact, this IC is the one that sends the switch command to the power supply. Therefore, once we've established the output voltage, we will proceed to test the diodes located on this board. So we need to disconnect at least one of its leads from the circuit board to test it easily. Alright, so we've successfully detached these two diodes, and the next step is to test them thoroughly to determine whether they are functioning correctly or if there's an issue. You know how to test a diode, right? Current should only flow in one direction. It should have current flowing in this direction, and it does. Then we'll reverse the direction to check again. This time you can see it's conducting current in this direction as well. This means the diode is faulty, it has a short circuit and must be replaced. Next, we'll check the other diode. This smaller diode exhibits an open circuit, meaning it prevents current flow in one specific direction, particularly from its cathode to its anode. From anode to cathode, it does. So this diode seems to be fine, but since it was next to a faulty diode, it's better to replace this one too. So we're going to replace the old diodes on this circuit board with these two new ones. Okay, I've replaced the diodes here, and after swapping them out, I'm going to plug the power supply back into the outlet. I'll go ahead and flip its switch, and then, what will be my next step? I'll remeasure the standby voltage to confirm whether it's actually there or not, ensuring everything is as it should be. Therefore, we'll set the multimeter to the DC voltage range and then connect the black probe to one of the black wires to ensure a proper connection for accurate voltage measurement. We'll position it here, then using the red probe, which is the positive probe of the multimeter, we will check the voltage on the purple wire to determine if the standby voltage is now present. Alright, let's plug in the power supply and power it up. Once that's done, we'll connect the red probe to the purple wire to see what happens. What's the result going to be? Alright, as you can observe here, the standby voltage is now reading around 4 point something, nearly 5 volts. So, the issue with the standby voltage, or rather the entire standby circuit, has been fully resolved up to this point. You've now learned precisely how to follow the steps to bring the standby voltage back to exactly what you see displayed here. Even though the voltage is slightly low, this reduced voltage is directly associated with the standby capacitor, which is situated precisely at this location. Observe, here, you will notice 3 small capacitors that are commonly referred to as startup capacitors. 2 are situated here, opposite the transistors you see, and 1 is found in this section. Now this specific capacitor situated close to the standby transformer is an integral part of the standby circuit. If you observe that the standby voltage is indeed present, but it measures slightly below the expected 5 volts, then it's highly recommended that you replace that capacitor to ensure the issue is completely and thoroughly resolved. However, here we clearly have the standby voltage, as you can readily observe, and when the standby voltage is present, it explicitly indicates that voltage should also be available on the green wire. So let's test it once. You can see that yes, the green wire also has a voltage of nearly positive 5 volts. Therefore, with the standby issue of this power supply now fully resolved, the next crucial step is to proceed with comprehensive testing and powering up the unit to determine if the power supply will successfully initiate and function as expected. Because resolving the standby problem, even when fully addressed, doesn't inherently ensure the power supply will necessarily power on. This is a crucial distinction to remember as we proceed. The power supply might not even turn on at all, but here we simply didn't have the standby voltage. My goal was to instruct you on how to troubleshoot the standby circuit, identifying precisely which components to replace so that your standby voltage returns and is present, just as you can see it here. This means that the voltage on both the purple and green wires, as you observed here, should register at a positive 5 volts. Therefore, using the techniques you've acquired thus far, you will systematically trace the standby circuit's path, meticulously testing all its components, from the transistor all the way to the transformer, to ensure their proper functioning. In the upcoming session, to ensure your comprehensive understanding, I intend to fully dissect the standby circuit. Our aim is to conclusively cover the standby chapter, guaranteeing your complete mastery before we transition to exploring the other critical sections of the power supply unit. As noted, a power supply comprises numerous sections. I have dedicated a chapter to each, and within that particular chapter, I will solely address that specific subject. Just as I first familiarized you with the power supply, here you've learned about the standby circuit, though there's still one more lesson left. After the standby circuit, we'll move on to the control circuit, or the switching circuit, so you can learn how to troubleshoot that as well. We'll cover symptoms of a faulty switching circuit, gradually making us more proficient with the power supply. So, the next step is a complete breakdown of just the standby circuit, so you can become fully familiar with the schematic, components, and structure of the standby circuit itself. After the standby circuit, we'll move on to the switching circuit. So far, you've witnessed how we troubleshoot the standby circuit and which components we replace. You observed that we commenced with the 2N60 transistor positioned here, then proceeded to examine the preceding resistor. Subsequently, we investigated the diodes, the transformer itself, and the diodes situated after the transformer, ultimately witnessing the problem's resolution. Meaning, our final problem was with the diodes located here, which are connected to this transformer. Immediately after the transformer's output, there are two diodes, one large and one smaller. We tested them, found the larger one faulty, replaced it, and our standby voltage was restored. There's a very crucial point I want to emphasize right now. If you have meticulously performed all the steps we outlined, replacing and testing every component with new ones, and yet you still find yourself without any standby voltage, then it definitely indicates that this specific transformer is defective. At that point, your course of action would be you should replace the current transformer with one that has the exact same part number written on its casing. You can even acquire many broken power supplies to serve as what we commonly refer to as donor power supplies, allowing us to salvage components from them. Some power supplies have a burnt-out switching circuit or a bad capacitor and have been set aside, but their transformer is still good. You can very easily use the transformer from that power supply as a replacement for the specific transformer you need for the power supply you are currently repairing.